Welcome! In this tutorial, you will learn the Android Workflow Foundation in ScreenLane version 0.2. This release does not take control of a phone. That is intentional. It gives an agent a safe, local way to state what it wants to inspect or do, check whether the request is allowed, collect approval when an action needs it, and save a receipt before a future companion bridge executes anything. By the end, you will have run the doctor command, planned inspection and action requests, seen an action wait for approval, seen a sensitive application blocked, inspected the local receipts, and called the same workflow through the local HTTP API. The problem is simple. A request like tap the new note button sounds harmless until an agent is allowed to execute it without context, approval, or a record. The same capability becomes much more dangerous in a banking application, a password manager, or a system settings screen. ScreenLane separates planning from execution. Planning is local and available today. Execution remains unavailable until a paired Android companion bridge exists. That boundary is the foundation of the workflow, not a missing feature to work around. Start by installing ScreenLane globally, or run it with the package runner. You need a recent node environment. Then run ScreenLane in it once to create the local configuration and storage directories. Android receipts are stored locally under the ScreenLane home directory. They are ordinary JSON records, so you can inspect them with your own local tooling. Nothing in this tutorial requires a cloud key because the Android Workflow Foundation is local. Keep that in mind as we work. Local planning is useful even before a physical device connection exists. Our first command is ScreenLane Android Doctor. Doctor answers two different questions. First, is an Android companion bridge configured? Second, what safety policy will ScreenLane apply when it plans an Android request? On a clean setup, the bridge reports not configured. That does not mean Doctor has failed. It means ScreenLane is accurately telling you that it cannot execute a device action. The report also lists the permission model. Inspect is allowed without approval, while tap, type, and scroll require approval. Finally, it lists sensitive app classes that policy blocks. Read the next step and the doctor response carefully. When no bridge is configured, it says to install and pair the Android companion before any device action can run. Do not treat an environment variable or a planned action as proof that a phone was controlled. The current bridge status is separate from an approval decision. This tutorial will make that distinction visible. A request may be approved and recorded, yet still not execute because there is no companion bridge. That is the correct and safe result for version 0.2. Next, plan an inspection. Run ScreenLane Android Plan with Action Inspect and an app identifier, such as com.example.notes. Inspection does not need explicit approval because it is not an instruction to tap, type, or scroll. ScreenLane returns a receipt with a ready status. The reason explains that inspection is allowed, while device execution still waits for a paired bridge. Notice that the receipt still records bridge not connected. Ready means the plan passed policy, not that anything happened on an Android device. The app identifier is important. Use a stable package or application identifier that your workflow recognizes. In this tutorial, we use a benign notes application. You can also attach before evidence with the optional before evidence flag. That value can refer to a screen context or capture receipt your surrounding workflow collected before making the Android plan. ScreenLane records that identifier in the receipt. It does not invent screenshot evidence, and it does not claim a device state it cannot verify. Evidence should come from your own capture step. Now plan a tap. Use Action Tap, the same app identifier, and a visible target, such as New Note. Tap requires a target because an action. Description without a target is not specific enough to audit. If you leave out the target, ScreenLane returns an error that the Android tap requires one. Include it, but do not include approved yet. The receipt status becomes pending approval. The reason is explicit. Approval is required before an Android action can run. This is a useful result. The agent has expressed intent, but it has not crossed the approval boundary. At this point, inspect the receipt rather than racing to the next command. It includes an identifier, timestamp, action, application identifier, target, status, reason, bridge state, and optional before evidence. Those fields make a small but useful audit trail. An operator can answer what was requested, where it was aimed, why it did not run, and whether there was evidence before the request. The receipt is written locally even for a pending request. That is deliberate. A pending decision is still meaningful operational history. When a human or a higher-level policy has approved the exact action, repeat the plan with the approved flag. The same tap request now has a ready status. Its reason says the approved action was recorded and that a paired bridge is still required before execution. This is the central distinction in the tutorial. Approval unlocks the plan. It does not bypass the bridge requirement. If the bridge is not connected, ScreenLane has not tapped anything, and its receipt says so. Your automation can use this state to guide the next safe step instead of pretending the action completed. Type and scroll follow the same model. Type needs a target because the receipt should identify the text field or visible destination. Scroll is an action too, so it requires approval even when no target is supplied. The policy is intentionally simple in this foundation release. Inspect is non-action planning, tap, type, and scroll are approval-gated planning. If you need richer constraints such as allowed targets, time windows, or organization-specific rules, apply them in your orchestrator before asking ScreenLane to record the final Android plan. Now test the sensitive application policy. Try to plan even an inspection for an identifier containing a protected class, such as bank, payment, wallet, password, credential, authenticator, or settings. ScreenLane returns blocked. This happens before approval is considered, because the protected class itself is not available to this workflow. The receipt records that policy decision and the reason. Do not evade this by renaming an identifier. The list is a conservative starter policy, and production integrations should provide accurate app classification plus their own controls. The important behavior is that policy comes before execution. You can list the audit trail with ScreenLane Android receipts. The newest entries appear first, up to a local limit. You should see the pending tab, the approved tab, the blocked sensitive request, and your inspection request. Each file is stored in the local Android receipts directory under the ScreenLane home. Receipts are not a remote telemetry feed, and no cloud credential is needed to create them. Treat them as local workflow evidence. If your organization needs centralized audit storage, export or ingest them through your own approved process after reviewing the data you are sending. The Android functions are also available through ScreenLane's local HTTP server. Start it with ScreenLane Serve. By default, it listens on localhost port 3070. The Android Doctor endpoint is a GET request to /v1/screenlane/android/doctor. To create an Android plan, send a post request to /v1/screenlane/android/actions with a JSON body containing action, app ID, and, when appropriate, target and approved. The receipts endpoint is a GET request to /v1/screenlane/android/receipts. The HTTP behavior matches the CLI behavior because both call the same local policy functions. For example, a post body with action tab, app ID com.example.notes, and target new note returns pending. Approval unless approved is true. Adding approved true produces a ready receipt, but still reports the bridge as not connected. A body targeting a protected identifier returns blocked. Build your client around those explicit statuses. Do not infer completion from a successful HTTP response. A successful response means ScreenLane handled the planning request and saved the receipt. The receipt status and bridge field tell you whether policy allowed the plan and whether execution could exist. If you expose the local server beyond a trusted local environment, enable its authentication requirement and provide the configured key in the authorization header. Keep the Android companion bridge local and deliberately paired. Avoid placing approval decisions in a client that can silently retry requests after the user has moved on. The safest automation is explicit about the proposed action, specific about its target, bounded by a fresh approval, and able to display the resulting receipt to the operator. Let us review the workflow from start to finish. Initialize ScreenLane. Run Android Doctor and read both the bridge state and policy. Capture your own before evidence when your use case needs it. Plan inspection without approval. Plan tap, type, or scroll with an exact target when required, then expect pending approval. After explicit approval, create the approved plan and confirm the receipt. If there is no paired bridge, stop there. If a sensitive application is involved, expect blocked. Finally, list or export the local receipts as your audit evidence. ScreenLane version 0.2 is designed to make the safe state obvious. It does not make claims about device execution. It does not turn approval into a hidden side effect. It does not accept protected app classes. Instead, it creates a clear record of intent, policy, approval, bridge readiness, and outcome. That gives teams a dependable place to build from as the Android companion bridge is added. Use the commands from this tutorial in a local project, inspect the JSON receipts, and keep your automation honest about what has and has not run.